Hello, and welcome to Newton's Bench Lab number 6. This one is on conservation of energy. And my name is Greg Perugini. And in this lab, we'll be using the same equipment that we used in the previous lab. A ramp set up with a marble that we'll be rolling down to verify our conservation of energy estimate for the velocity at the end of the ramp. If we look at the beginning, when the ball is at the top, there is no kinetic energy. It's just held there. There's no velocity. It's all potential energy due to gravity. At the bottom, of course, it's going to be all movement. No potential energy because it's going to be at the bottom. Y is equal to 0. So you're going to need a good measurement here of the height of the ramp. If there is a difference between these two, that is going to be a loss in the system to a non-conservative force. And that non-conservative force is friction. Work done by friction. Work being force times the distance. Force in terms of friction being the coefficient of rolling friction that we got in the previous lab times the normal. Well, the normal, based on ramp physics that we did in the previous lab, we can either measure the length of this and the height and using tan inverse get the angle, or use your protractor to get the cosine of the angle. Mg times cosine of the angle will give you the normal. Hence, work is equal to the coefficient of rolling friction that we got in the previous lab times mg cosine of the angle times the distance down the ramp. That whole distance from the top to the bottom. So, if at the beginning kinetic energy is 0, and at the end, potential energy is 0, we can write the equation where y initial at the top, this is at the beginning before we move it, is equal to the after, all kinetic energy, but we're going to take into account the rolling friction as well. And if you look at that equation, mass cancels. So this gives me the equation that we will use, given the very specific rolling friction coefficient that we got in our previous lab, using the angle, now that we have this at a different angle and a different height, and the distance down the ramp, we can solve for the velocity at a final position. Should be fairly accurate. And with that, I want you to do 5 trials of this going down the ramp and verify your work on this equation. And that's conservation of energy.